Thanks, Samir. I will score good. Because I understood about balancing the chemical equation last night, explained by you.
My pleasure. And I am happy for you.
Hey. Sania told me that you helped her in balancing the chemical equations.
Yes, I did.
If you don't mind, can you help me also? As I have some doubts in it.
Sure. I would love to.
I will send you the doubt list of it.
Okay, then meet me online today evening.
Fine. See you online. Bye. Later in the evening.
Hello, Rose. Now I will share my screen.
Yeah, sure.
Rose. I want you to note down and practice to it. Let's begin.
Screen sharing.
New chemical reaction where we have carbon reacting with sulfur, giving us carbon disulfide. So in the given reaction, when we see the element involved is carbon and sulfur, let us take the number of carbon atoms present on the reactant side. When you go to see there is nothing, means again it is 1, so I'll write 1 there. Number of carbon atom on the product side is nothing, means again it is 1, so I'll put 1 there. Similarly, number of atom of sulfur on the left hand side is 1, so I'll put 1. But the number of sulfur atom on the product side is 2, so here I will put 2. When you compare carbon atom on the reactant as well as on the product side, it seems to be balanced. But when you compare sulfur atom on reactant and product side, it is not balanced. So we'll have to balance this. In order to balance this, we are going to use the same pattern. As we have 1, we can make it 2. So I'll just simply multiply it by 2. When I multiply it by 2, it becomes 2. So I am multiplying 2 to which element? With sulfur. On which side? On the reactant side. Let's go up. Do we have sulfur alone on the reactant side? Yes. So I'll just simply put there 2. Once I check, carbon was already balanced with 1, 1. Now even sulfur is balanced with 2 and 2. So what is my final tally? That carbon with 1 atom, sulfur with 2 atoms. Hence, you check this out. That carbon with 1 atom here, carbon again with 1 atom here, sulfur with 2 atoms, and sulfur. Example as lead, oxide on heating gives us lead monoxide and oxygen. The element involved in the above chemical equation is lead and oxygen. Now let us take account that the number of atom of lead on the reactant side, nothing, means 1. Same way the number of atom of lead on the product side is also 1. Moving on to oxygen. The number of atom of oxygen on the reactant side is 2, whereas on the product side it is nothing, means 1, and this 2, which means 1 plus 2, that is 3. Now let's tally on the reactant and on the product side. If you check, lead is balanced as 1 and 1 atom, whereas the oxygen atom on the reactant and the product side is not balanced because it has 2 and 3 atoms. So how are you going to balance it? So there are 2 ways of balancing it. Like here we have the different numbers. So if you want, you can go with the LCM method and get the answer, or you can also go with the other method. The other method which we are going to use over here, we have already seen this in the previous part in one of the reaction, as instead of making it 2 as 3, just take it as double. So I am multiplying lead on the reactant side by 2. So I multiplied 2 to the lead on which side? On the reactant side. But when I go up, do I find lead alone? No. So I'll have to put this 2 here. Similarly, I will also multiply 2 to my product side. So to this lead atom only, I'll multiply 2 to the lead on the product side. But when I go up, do I find lead alone over here? No. Still it is in the combined form, so I'll put 2 there. Once I'm done with that, let's tally how many atom of lead are there? So here we have 2 and 2. So lead got balanced, but because this 2, which is equal distributed through both, the oxygen got changed. Earlier the oxygen was 2, now 2 to the, it became 4. This one was earlier 1 oxygen, but now 2 1 the 2, and this 2. Okay, so 2 plus 2, it also got changed to 4. So if we see now and tally lead and oxygen, both of them are balanced. So what are the coefficient which I am going to write down? Will be 2PbO2 on heating gives 2 PbO and oxygen. When you tally them, it is lead as 2 atom. Over here, lead again has 2 atom. Oxygen 2 to the 4. This 2 plus this one, 2 on the 2. So on adding, it also becomes 4. Hence, everything seems to be equal. When everything is equal, then the reaction is balanced. With the next chemical equation, where we have zinc reacting with hydrochloric acid, giving us zinc chloride, and hydrogen gas is released. So in the above chemical equation, the elements which are involved are zinc, hydrogen, and chlorine. Let us take account that the number of atom of zinc on the reactant side is nothing means 1. Number of atom of zinc on the product side, again it is nothing means 1. Similarly, let us take the count of hydrogen on the reactant side is again 1, but here on the product side we have it as 2. Looking at the chlorine, no number means again it is 1 on the reactant side, but on the product side it is clearly mentioned as 2 atom of chlorine. When we try to compare the reactant and the product side with the number of atom for the zinc, it seems to be same, so it's balanced. So zinc is balanced. But what about hydrogen and chlorine? On the left we have 1, but on the right we have 2. Are they balanced? No. So chlorine and hydrogen are not balanced. So how are we going to balance this? As zinc is balanced, so we should not touch it. Let's start with hydrogen. We have 1, we have 2 over here. We all know that making 1 as 2 is very simple, but just multiplying it with 2. So when I multiply 2 to which element? To hydrogen. On which side? On the reactant side I get 2, which becomes equal. So I'll go up on the reactant side. Do I have hydrogen alone? No. It is in the combined form, but still I will put 2. The moment I put this 2 is for both. It will get equally distributed and will bring the change in both the count. The hydrogen, which was 1 earlier, now became 2 1 the 2. Same way, even the chlorine, which was 1 earlier, now will become 2 1 the 2. The moment I write 2, it seems chlorine on reactant and product side, the number of atom of chlorine also gets same. So in this way, both of them get same very easily. So what is my final coefficient which I am going to write? Zn as same. I'll just put this 2 over here. Just all same. If you want to tally, you can tally this further. Zinc as 1 atom. Zinc as 1 atom. Hydrogen as 2 1 the 2 atom. Hydrogen as directly 2 atom here. Chlorine as 2 1 the 2 here. Chlorine is directly written as 2 here. Hence the chemical equation is balanced. Moving on to the next chemical equation, where we have potassium chlorate, which is heated up to a certain degree temperature in the presence of a catalyst as manganese dioxide, which results into KCl, potassium chloride, and oxygen gas is evolved. Let's write the element involved in it. We have potassium as K, we have second element as chlorine, and the third one as oxygen. Let us see the number of atoms of each on the reactant as well as on the product side. So when I see potassium on the reactant side, it is 1, so I will write it as 1. On the product side it is 1, so I will write it as 1. Similarly, chlorine, nothing means 1, so on the reactant side chlorine atom is 1. Nothing means again 1, on the product side is again 1. But when I see oxygen on the reactant side, I have 3 atoms of oxygen, but on the product side, I have 2 atoms of oxygen. When we go and check the potassium, it seems to be equal number of atoms on the reactant and the product side, so it is balanced. Similarly, for chlorine, they are same, 1 and 1 on each side, so even chlorine is balanced. But what about oxygen? Here on the reactant side we have 2, but on the product side it is, reactant side we have 3, product side it is 2, so it is not balanced. So we need to balance oxygen first. As we can see, potassium and chlorine are already balanced with 1 and 1. So we'll go for oxygen, but here we have different number. We have 3 as well as 2. So I can't make 2 as 3 and I can't even make 3 as 2 because they are not even numbers. In this case, I'll go with LCM. So what will be the LCM for these two? The LCM for the above two number, that is 3 and 2, would be 6, which means I will multiply oxygen on the reactant side with the number as 2, which will result into 6. So I am multiplying to oxygen on which side? On the reactant side. Let's go up. Do I have oxygen alone over here? The answer is no, it is in the combined form, but still I'll put this 2 commonly for all. Same way, I will multiply product side also with the 3 here in order to make it as same as 6. So I am multiplying 3 to oxygen. On which side now? On the product side. Let's go up. Do we have oxygen alone over here? Yes. So I'll put 3 there. Then I find that oxygen is balanced now. But what about this 2? This 2 is equally for all of them. So because of this 2, this all the number of atom got changed. Earlier potassium was 1, but now 2 ones are 2. So it was 1, it became 2 now. Same way chlorine was also 1, but now because of this extra 2 there, it also changes to 2. The one which was earlier balanced is now no more balanced. So in order to balance this, we all know it is very simple to make 1 as 2. We just have to multiply this by 2. So I will start with potassium. I am multiplying potassium now by 2 on which side? On the product side. Do I have potassium alone? No. But still I will take this 2 common. Right? Once I take it as common, this 2 and this 2, potassium gets balanced. But similarly, this 2 which I have written will be equally for both of them. Hence, chlorine which was 1 will also get balanced. Will automatically changes to 2. So if you check, even the chlorine gets balanced. So this is how all my element gets balanced. So what is my final coefficient? We'll be writing over here. The above one is 2 KClO3. That is 2 KCl plus 3O2. I hope if you want to check, you can tally it. 2 ones are 2 potassium. 2 ones are 2 potassium. 2 ones are 2 chlorine. Same way, 2 ones are 2 chlorine. 3 2s are 6. 3 2s are 6. Hence the above reaction is balanced. One more chemical reaction wherein we have sodium added to water, which gives us sodium hydroxide and a hydrogen gas is evolved. In the above reaction, the element involved are sodium, hydrogen and oxygen. Now we will be writing the number of atom of each on the reactant side as well as on the product side. The sodium atom, there is no number on the reactant. It means it is 1 atom of sodium. Similarly, no number means 1 atom of sodium on the product side 2. Hydrogen on the reactant side is written as 2. So I will write 2 there. Hydrogen on the product side, there are 2 hydrogen, 1 and this 2. So which means 1 plus 2, that is 3 hydrogen. Oxygen on the left side, there is no number, reactant side, so it is 1. Oxygen on the product side is also 1. So when we see now, sodium seems to be balanced, even oxygen seems to be balanced with 1 and 1, 1 and 1. whereas hydrogen is not balanced. Let us try to balance this first, as sodium and oxygen seems to be already balanced and hydrogen is not. So instead of going with hydrogen first, let's go and make this as double as we have done in previous equations also. So I am multiplying 2 to sodium to make it as 2. Multiplying 2 to sodium on the reactant side. When I go up, do I find reactant alone? Yes, so I'll put 2 there. Same way I will multiply 2 to the product side also to make it as balanced. So I am multiplying 2 to the sodium on the product side. Do I find it alone? No, it is in combined form, but still I will take 2. Now this 2 which I have taken is for all. So this sodium became 2 on both the sides, becomes balanced, but the side right side one makes the changes as it is distributed to all, so it will go for all. Now the oxygen which was 1 automatically changes to 2. Hydrogen which was 2, which was 1, now it becomes 2 to the 2 on the 2, so it will change to 2, and when you see 2 plus 2, it becomes 4. Because of this, even oxygen got unbalanced and hydrogen is still unbalanced. But if you want, we can make this oxygen as balanced by just making this 1 as 2. So now I am multiplying 2 to oxygen. On which side? On the reactant side. Do I have oxygen alone? No, it is in the combined form. But still I will take 2 there. So once I take 2 there, oxygen gets balanced. But what about the hydrogen? 2 to the 4. It also changes the hydrogen from 2 to 4. So when you compare each one of them, you will find all of them are same, balanced. 2, 2, 4, 4, 2, 2. So what is my final tally now? I have 2 Na plus 2 H2O plus 2 NaOH. Hence my reaction is balanced. If you want to tally, you can go ahead. Sodium atom 2, sodium atom 2 on the 2, hydrogen 2 to the 4, 2 here and 2 here, 2 to the 4, oxygen 2 on the 2, oxygen 2 on the 2. Hence everything is balanced. Moving on to the next chemical equation, where we have calcium carbonate reacting with hydrochloric acid, which is heated up to 200 degrees Celsius, resulting into calcium chloride, water molecule, and a gas, carbon dioxide. Let us take the element involved in them. One of the elements is calcium, then we have carbon, then we have oxygen, hydrogen, and the last one is chlorine. So total of 5 of them are involved in the above chemical equation. Let's take the count on the reactant side, which element are there and the number of atom involved in them. So calcium on the reactant side is only 1, whereas calcium on the product side is also 1. Carbon on the reactant side, no number, means 1. Carbon on the product side, again 1 with no numbers. Oxygen on the reactant side is 3. Oxygen on the product side, we have 1 here and 2 here, which means 1 plus 2, that is 3. Moving on to hydrogen, on the reaction side it is 1. On the product side it is 2. Chlorine on the reactant side is 1. And the chlorine on the product side is 2. Let's check out. Calcium is already balanced with 1 and 1. Carbon is also balanced with 1 and 1. Oxygen is also balanced with 3 and 3. Hydrogen is not, as well as chlorine is not balanced. We will have to balance these two first. We all know it is very easy for making the change. As we have hydrogen 1, I'll just multiply it with 2 and I get 2. So I am multiplying 2 to which element? Hydrogen. On which side? On the reactant side. Let's go up. Do I have hydrogen alone? No, it is in the combined form. So I'll put this 2. Right? The moment I put 2, I see that hydrogen gets balanced. As the other one was already balanced, even hydrogen got balanced. But because of this 2, which is equally distributed to both of them, it also brings the changes to the chlorine. Earlier it was 1, now 2 ones are 2. So it will automatically changes to 2. And when you compare, even chlorine got balanced by just bringing 1, 2 above. So what is my final coefficient? That is CaCO3 plus 2HCl gives CaCl2, H2O and carbon dioxide. Hence the reaction is balanced. Let's see one more, which is having sodium sulfite when reacted with HCl, hydrochloric acid, results into sodium chloride with water and a gas is evolved, that is sulfur dioxide. In the above chemical equation, the elements involved are sodium, sulfur, oxygen, hydrogen and chlorine. Again 5 of them. Let's count the number or write the number of atoms present on either side. Sodium. On the reactant side, we have 2 atoms of it. But on the product side, there is nothing, means 1. Sulfur. Nothing, means 1 atom of sulfur on the reactant side. Similarly, 1 atom of sulfur on the product side, 2. Oxygen, we have 3 atoms on the reactant side. Oxygen, we have 1 here and 2 there, which means 1 plus 2, that is 3 atoms. Hydrogen, 1 atom on the reactant side, 2 atoms on the product side. Chlorine, 1 atom on the reactant side and 1 atom on the product side also. When we check now, it is seen that sulfur, oxygen and chlorine are already balanced, whereas sodium and hydrogen are not. So let's start with the first atom only. Where the first element is sodium, we have 2 here and 1 here. So we all know it's very simple to make it as 2 just by multiplying it with 2. So I am multiplying 2 to which element? To sodium. On which side? On the product side. Let's go up. Do we have sodium alone? No, it is in the combined form, but still I will take this 2. Because this 2, sodium got balanced, but this 2 is equally distributed for all and it will bring the change even to chlorine. Chlorine, which was 1 earlier, will now change to 2. Hence, it got unbalanced now. As chlorine got unbalanced, which is 1 and 2, so again it is very simple for us. Just multiply the chlorine by 2, so it will get balanced. So I am multiplying chlorine by 2. On which side? On the reactant side. Let's go up. Do we have chlorine alone? No. It is in the combined form with the hydrogen. So we got chlorine as 2 and the chlorine got balanced. Now this 2 is equally distributed for both, as we have seen for so many reactions. So hydrogen will also change from 1, now it will change to 2. As it changes to 2, we see on the reactant and on the product side, hydrogen already, along with this, hydrogen also got balanced. Hence, on comparing, we find sodium as 2s, 2 and 2 balance, sulfur 1, 1 balance, oxygen 3, 3 balance, hydrogen 2, 2 balance, chlorine 2, 2 balance. So what will be my final coefficient in my reaction? Answer, it will be Na2SO3 with 2HCl gives 2NaCl plus H2O plus SO2. If you go and tally, 2 atom of sodium, 2 atom of sodium, 1 atom of sulfur, 1 atom of sulfur, 3 atom of hydrogen, 1 plus 2 atom, that is 3 atom of oxygen, 2 atom of hydrogen, 2 atom of hydrogen, 2 atom of chlorine, 2 atom of chlorine. Hence, everything is balanced now. Let us take one more chemical equation where we have FeCl3 and 3 chloride reacting with ammonium hydroxide, resulting into iron 3 hydroxide and ammonium chloride. The element involved in the above chemical equation is iron, Fe, chlorine, nitrogen, hydrogen, and oxygen. Let us write the number of atoms of each from left and right, that is reactant and product. So Fe on the left hand side, there is no number, means it is 1, so I'll write it as 1. Fe on the product side, again as 1. Chlorine on the reactant side is 3. Chlorine on the product side is 1. Nitrogen on the reactant side is 1. Nitrogen on the product side is also 1. Hydrogen, we have it in two parts. Here we have 4, here we have 1. On adding, it becomes 4 plus 1, that is 5. Same way, hydrogen, again we have it in two parts. This 3 which is there outside the bracket is equally distributed for both of them. So here the hydrogen becomes 3 on this side, plus this has 4. So 3 plus 4, it is 7 now. Moving on to oxygen, there is no number, means it is 1. And here, as I said, this 3 is equally for both, so even 3 oxygen also becomes 3 over here. Let us check and start balancing. So when we go and check, Fe is balanced as 1 and 1. Chlorine is not, as it has 3 and 1. So we all know it is very simple to make 1 as 3. Just multiply this by 3, it will get balanced. So I am multiplying 3 to element chlorine on the product side. So when I go up and check, I don't find a chlorine alone, but still I will take this 3 common for all. Hence my chlorine gets balanced. But this 3 will bring the change in all. Nitrogen, which was 1 earlier, will now become 1 3 the 3. Oxygen, which was 4, now it will become 4 3 the 12. Right? But still I have 3 over here. So 12 plus 3, it will finally become 15. And the chlorine also gets changed to 3, that we have already written. So now 2 of them are balanced. Moving on to nitrogen, it is 1 and here we have 3. So to make this nitrogen balance, I am going to multiply nitrogen by 3 this time. So I am multiplying nitrogen element on the reactant side. As I go up and check, nitrogen is again not alone, it is in the combined form, but I'll take this 3 commonly for all. The moment I take this 3, it changes all the number of atoms. Nitrogen becomes 3, so it is balanced, but this 3 will also change the hydrogen atom. Right, now 3 4 the, it will become 12. Here we also have 1, so this 1 and 3, 1 3 the 3. So we have 12 and 3. On adding, it will be 12 plus 3, which will bring it to 15. And when you check the 15 15, even hydrogen got balanced. Just like that, look at this oxygen, which was 1, but now combining with 3, so it will become 3. It will automatically change the oxygen also to 3. So when you look around, all of this are balanced now as 1 1, 3 3, 3 3, 15 15, and 3 3. So what is my final tally? And the coefficient would be 1 FeCl3 with 3 NH4OH gives FeOH thrice plus 3 NH4Cl. On comparing, you will get to see that everything is balanced, hence my chemical reaction is balanced. Let's take one more chemical equation for balancing. We'll start with the reactant. We have lead nitrate reacting with ammonium hydroxide, giving us ammonium nitrate and lead hydroxide. So the way we used to do, we are going to write the same manner, that which all elements are involved. So we have lead over here along with nitrogen, then we have oxygen, and last we have hydrogen. Even we used to find out that how many atoms of each are present in it. So for lead, it is 1 on the reactant side. Similarly, lead 1 on the product side too. Nitrogen, we have inside 1, but we have a bracket, and outside bracket we have this 2. So this 2 which is there is for both. So nitrogen over here is 2, but we have one more nitrogen here, in the other second reactant, that is 1. The total it becomes 3. Just like that, on the product side we have 1 nitrogen here and 1 more nitrogen here. So total 1 plus 1 is equals to 2. Moving on to oxygen, as I said, this 3 and this 2 will get equally multiplied. So oxygen plus this 3 to the 6 plus 1 7, so it will be 6 plus 1, that is 7. On the right hand side we have 3 oxygen here plus this 2 which gets equally distributed to both of them, so 2. Total of 5. Hydrogen, on my reactant side we have 4 hydrogen with this plus 1, that is 4 plus 1 equals to 5, and on the product side we have 4 with this 2, so 4 plus 2 becomes 6. So this is how we find out that number of atoms of each present in the chemical reaction. We are going to check whether the reactant and the product are same for each of the element or not. So for lead it is same, but for nitrogen it is not, for oxygen it is also not, and hydrogen is not. So we are going to follow the same pattern, make converting 1 into 2 or 2 into 3, or we might take some LCM and we'll get it. But this sum, this equation will not get balanced easily with this method. It will be very lengthy and time consuming. So what we need to do? How are we going to do this? So we are going to make some changes. Now what are these changes? Let's see. So the change which we are going to bring will bring in the element part. Earlier we used to write them individually, but now we are not going to write them individually anymore. We are going to change it. Okay. Now how it got changed? Let's see. We will take the lead as same, but because lead is alone. But when I come to NO3, which is a radical, right? So I'm going to take this radical together as NO3. Same way, when I go ahead, I find this NH4 ammonium, which is another radical. I will take that ammonium radical also together. Moving on to OH, which is one more radical as hydroxide. So I will group up the radicals and I will take them together. And now I am going to see how many of them are present in the on the reactant and on the product side. On the reactant side, I find lead as 1, so I will write 1. On the product side, I find lead also as 1, so I will write 1. Then nitrate. If you see, nitrate is in the bracket, right? Nitrate is in the bracket. It means NO3, but outside the bracket we have number as 2. So which means this nitrate is how many times? Twice, 2 times. But on the right hand side, do I find any bracket over here? No, I don't find any bracket over here. So if no bracket, then it is open. It will be considered as how many times? Only 1 time. After this, I'm going to go ahead with ammonium. If you see ammonium is also not placed in the bracket. So it means whole NH4 is only taken as 1 time. When you go to the product side, again NH4 is not in the bracket. So it will be considered as together as only single time. Moving on to the next one, where we find the last one as hydroxide. So if you look at the hydroxide, it is also alone. Alone means take it as 1, but here hydroxide is in the bracket with the number outside as 2. So we'll have to take twice 2. And now we are going to balance them with the previous method. So lead is already balanced, no need to do anything to it. But NO3 nitrate, here we have 2 and here we have 1. So we all know that how can we convert this 1 as 2? By simply multiplying it with 2. So when I am going to multiply this 2 to which radical? To nitrate this time. On which side? On the product side. But as I go up, do I find nitrate alone? No, it is in the combined form, so I'll have to take it as 2. Now the moment I take it as 2, this ammonium, which was single earlier, will now become twice. So when it becomes twice, the ammonium which was 1 now will change to 2. Right? Moving on. Our nitrate got balanced, but the remaining two are not. Look at the ammonium. We have 1 here, 2 here. So we all know that we can easily make it as 2 by simply multiplying it with 2. So this time I'm going to multiply 2 to the radical ammonium. But on which side? On the reactant side. So when I go up, do I find reactant ammonium alone? No, it is in the combined form. So I'm going to multiply this 2 to ammonium. Now ammonium, which was only considered to be 1, because this 2 will become 2. So ammonium got balanced, and like that even it will bring the change to the hydroxide, which was open, means 1 time, and now it will become 1 to the 2. The moment it becomes 2, it seems that everything is balanced. Seems to be balanced. Now we are going to take this as so. The final tally in the answer after bringing the change would be PbNO3 twice as it is, but this NH4OH, the last one for this today's session, as copper sulfate reacting with sodium hydroxide results into copper hydroxide and sodium sulfate. Now let's write the element involved in them. We have copper, we have sulfur, we have oxygen, we have sodium, and we have hydrogen too. Now let's see the number of atoms of each on the reactant as well as on the product side. So copper with no number means 1 atom of copper on the reactant. Same way copper on the product side is also 1. Sulfur with no number means 1 on the reactant side. Sulfur with no number means 1 on the product side. Oxygen, we have 4 here. So oxygen 4, but we also have 1 here. So plus 1. So together it becomes 5. Oxygen, this 2 is for both of them. So we have 2 oxygen here plus last 4. So 2 plus 4, it becomes 6. Now finally we are going to take sodium. On the left hand side it is 1, so 1 atom of sodium, and here we have clearly 2 atom of sodium. Last is hydrogen. On the reaction side we have 1 atom of hydrogen. On the product side we have 2 atom of hydrogen. So we all know how to balance this because we have seen the pattern. Let's tally. If we see copper, on both the sides copper is same, balanced. Sulfur is also seem to be balanced, but oxygen is not, nitrogen is not, and even hydrogen is not. So how are we going to balance this with the previous and the older method? Let us start with sodium. As you can see, sodium we have 1. The above one are very much balanced, but oxygen is complicated. So let's start with sodium. I have 1 and 2. So I know that making 1 as 2 is quite easy. I just have to multiply 2. So I'm multiplying 2 to sodium. On which side? On the reactant side. When I go up, do I find sodium alone? No, it is in the combined form, but still I write 2 there. The moment I write 2 and 2, sodium gets balanced. But this 2 will definitely bring the change to all of it. So once it brings the change, sodium, Na, becomes 2. But what about the oxygen, which was 1? Now 1 to the 2. So it was taken as 1 earlier. Now it will change to 2. So it will become 4 plus 2. That is 6. It gets changed. Likewise, this 2 is also for hydrogen. So 2 on the 2. The hydrogen will also change. Now just compare copper with 1 and 1. Sulfur 1 and 1. Oxygen 6 and 6. Sodium 2 and 2. Hydrogen 2 and 2. Hence, we find that this 2 of them are almost same. So what is the final count? We just have to put 2 here, and rest all everything is balanced. So this is our balanced chemical equation. In the same manner, now I want to give you one as for trying. So I want you all to try this. Okay. So for trying purpose, we have a chemical reaction as zinc sulfate reacting with NaOH, sodium hydroxide, results into zinc hydroxide plus sodium sulfate. So try this and comment me your answer.
Screen sharing stopped.
I hope you understood everything. Hope so. You practice. All the best.
It was really helpful. Thanks a lot. Bye. Good night, Samir.